Hi, I'm Caroline Richards, and I'm really thrilled to be chairing this session today, looking at moving from biology through to behaviour, modelling cause and intervention for problem behaviours in children with intellectual and developmental disabilities. At the end of our set of talks today, we are really privileged to have Professor Frank Symons be pulling together these ideas as our discussant. So in this session today, what we are going to be looking at is a set of short talks as a data blitz. So we'll focus on the methods and the analysis and the results from these studies, with a view to identifying pathways from cause through to problem behaviour to better elucidate the kinds of interventions that will make a real world difference. We're going to start off at the biology end with a talk from Frank Symons on some of the biological biomarkers associated with the differences in sensory perception for people who show self-injurious behaviours. Next, we'll move to a talk from Catherine Laverty with data that she collected as part of her master's at Birmingham. She'll be sharing with us data on the longest community sample longitudinal study of problem behaviours in autism, looking to identify prevalence and predictors of aggression and self-injurious behaviour from mid-childhood through to adulthood. Next, we'll hand over to Adele Dimian, who is narrowing down our focus into the emergence of problem behaviours, particularly in very young infants, using a cohort of high-risk infant siblings. Next up, Laura Groves will take us in that translation from models of risk and prediction into clinical settings. Laura's going to be presenting some data from a study that is currently midway through, trying to use different approaches to modelling risk to stratify the delivery of clinical services. And finally, we will end up at intervention when Scott Hall will present to us data from an RCT using telehealth to deliver interventions for problem behaviours in Fragile X syndrome. So we look forward to all of the talks and to receiving your questions at the end.
I think I've got the first paper in today's symposium on From Biology to Behavior, Modeling Cause and Intervention for Problem Behaviors. Caroline Richards is the chair. Sadly, you get me 2 times. I think I closed this out as discussant, but I've got a paper in. Those of you who know me, we've got a program of work specific to self-injury and thinking about some of the biological correlates, and I've become more of an ambassador for a large group that includes a children's rehab hospital, Gillette Children's and Chantel Barney, and a number of bench folks at the University of Minnesota that know neuroscience and peripheral innervation. And I have a data set today I wanted to put in front of the Gatlinburg audience, our aberrant behavior audience. Remember in the old days, we used to be last session on on Friday mornings before everybody left, or Saturday mornings. So we've got an initial data set, small data set, and I'm exploring this idea of peripheral innervation and want to move into thinking about neural development across time and what would be typical. So those of you who've been following our program, you know I've made remarks before. The skin, to remind everybody, is our largest social organ, and I put an image there of Harry Harlow's pioneering work where isolate-reared primates would prefer the touch and tactile component, even though that mother was non-nutritive. But the skin also has a very important function role as a protective barrier. And to remind you, it has layers. And so our program of work, again, for many of you know this, we've been trying to think about integrative biobehavioral approaches where we sample biology and try to relate it to behavior. And in particular in the skin, you know, I have a saying about where behavior meets biology, and we're interested in sensory mechanisms. So just to orient you to this, this is a cross-section histological image from a peripheral epidermal skin biopsy. And we'll see this again. The blue is the epidermis background stain, and green in this image are nerves. Those are neurons, individual neurons, all the way out into epidermis. So those are important for transmitting information that primarily noxious information, tissue damaging information. Those are primarily unmyelinated, small unmyelinated C fibers. And why do we care? We care because we've made observations in the past from individuals with chronic self-injury from non-self-injury sites that the pattern of innervation seems different. On my left is a typical a normal image of the way that the innervation pattern works, and then on our right is a self-injury case, again from a non-self-injury site of profoundly different pattern of innervation. In this case, very sparse innervation. So we've moved that work. That was an image from adult into kids, into pediatric samples with global developmental delay that we consider an at-risk sample for intellectual disability and outcomes sometimes related to problem behavior in general and self-injury in particular. And we see enormous variation. The image on the left, the epidermal nerve fibers per millimeter, 200. Image on the right, 77. So we don't really know what the normal range of variability is. So I'm going to set this up with a few words and then into the data. So I'm going to repeat a little bit. To recap, we've made a series of observations over many years that the epidermal nerve fiber innervation in the skin may be relevant as a subclinical marker for biological vulnerability and self-injury risk. That's our long-term goal. In adults, as per that one slide I just showed, we've seen patterns that I will map onto either being very sparsely innervated or very densely innervated. And we also, within those particular neurons, stain in ways to look for neuropeptide content, substance P, and other relevant neuropeptides. We've moved this down into pediatric samples. And now the point of this talk is, there's very limited normative data. I found one paper that had looked at kids cross-sectionally, but of different ages, young children over different ages, not over time. And what I think I can say in front of a neuroscience audience and not be heckled, so I'll say in front of a behavioral science audience, is that I think ENF density values decrease with age. The density of innervation decreases over the early developmental period. So in this exploratory investigation, we were investigating epidermal nerve fiber density, that's that ENF, with young children with global developmental delay with and without parent-reported self-injury. So the self-injury outcome measure was through, no surprise with our group, the Repetitive Behavior Scale Revised, RBSR. We had a sample of 25 kids. We piggyback, as many of you know, on clinically indicated procedures where the child is sedated. Ethics are in place, IRB, parents, etc., to get a small sample of skin from the back of the calf. That calf is a site the lab has a built-up data set on what we should see there. So we importantly, at least on one way of a bias protector, the lab, the person doing the staining and the assays, that they're blind to status, the child status, and then they do a count. They quantify that epidermal nerve fibers, and we get a count per millimeter. So what did we see? We created two groups empirically. RBS scores over 3, RBSR scores under 3, 0 to 2. That was our data and histogram of this sample, again, of N of 25. In general, the minor no SIB there was a slight higher level of median value of epidermal nerve density, mean and median, relative to the severe SIB. And then we looked in using a regression analysis that the epidermal nerve fiber densities seem to be decreasing in age with the minor no SIB group, but remain relatively stable relative to the severe SIB group. So what does that look like? So blue here is the minor no SIB, and the density along the vertical axis is epidermal nerve fiber density. That's decreasing over time, over the age group we sampled. Whereas in the more severe cases, doesn't even look stable. It looks like it's increasing. But relatively, again, I think the normative perspective is the blue line, that in the one sample I could find, the epidermal nerve fiber density looks like the blue, the low risk for SIB, the minor SIB, and not like the red. So quickly, this is, for us, a large sample, again, getting more confirmatory evidence that there seems to be a lot of variability in epidermal nerve fiber density in these kids. The age-dependent decrease in ENF density may be disrupted. And what this is hand-waving part, does that have functional consequences specific to sensory function that's relevant to the initial emergence of self-injury? We don't know. We think it's worth thinking about and pursuing. And then again, I've said this before, but I'll say it again. A major concern, at least for me, is that we still don't have, there are no published reference values for typically developing children birth through 5. So it's still a little bit of a shot in the dark. And then last, because I've looked at the other talks in the spirit of modeling, and Brianne Byers gave an assist here, this figure is interesting to me. On the left, the pink, this is a modeling of at 36 months, what would you predict for SIB outcome based on the data being fed in? Well, the higher the epidermal nerve fiber density, the least likely you are to be an endorsed severe SIB case. But when you move ahead to the older part of the distribution, age distribution in this sample, the higher the density, the more likely you are to SIB. So it's flip-flops by age. And that's something, again, back to what the developmental trajectory is of the normal biology. And if we're deviating from that biology, what are the implications in relation to sensory function and SIB? And I'll stop there. Thank you.
Hi, my name is Catherine Laverty and I am a doctoral researcher based at the University of Birmingham. And today I'm going to be talking about a longitudinal prospective cohort study that I've been involved with. In this study, we were particularly interested in understanding the prevalence and predictors of aggression and self-injury in autism. And that's because we know these behaviours are predictive of poorer quality of life outcomes for both individuals and their families. And today I'll present a snapshot of this research and its main findings. So to begin, what do we know about self-injury and aggression? Well, first looking towards self-injury, the answer is quite a lot. Here's a recent meta-analysis where 37 studies of self-injury and autism were synthesised, generating high pooled prevalent estimates. And yet there is also much that we don't know. Many studies looking at self-injury often recruit participants from clinical pathways, where behaviours may not only be more common, but individuals may already be in a receipt of some form of service that could influence the presence of these behaviours. And we know even less about the prevalence of aggressive behaviours in autistic individuals. Unlike self-injury, these behaviours have not yet been synthesised, and prevalence is unclear despite the fact that these are still extremely problematic behaviours. And looking towards what we know so far about the development of these problematic behaviours, it's well established that these are operant behaviours that are sensitive to environmental and/or sensory reinforcement. And yet our group has been particularly interested in the fact that one key limitation of the operant model is not everybody who is autistic will develop these behaviours. And we've been interested in whether the identification of correlates might tell us something about mechanism. Which leads us on to our current study, which was a 3-wave longitudinal study that recruited a community sample. It was started in 2007, and these participants were followed up 3 years and 10 years later. It was a postal questionnaire that included a broad range of validated measures, along with background questionnaires that asked about things such as service access over time. And today I'll present our findings on 2 specific areas. Are self-injury and aggression persistent? And can we identify risk markers to distinguish those more likely to develop these behaviours? So considering first if behaviours are persistent, and looking towards the self-injury data, what we see is that persistence does appear to decrease over time. So initially at the 3-year follow-up, we see that self-injury was persistent for 77% of participants, but at 10 years, this has significantly dropped to 44%. And we see a similar pattern when looking at the aggression data. So at 3 years, aggressive behaviours were persistent for 67% of our sample. And by 10 years, this is more than halved to just 30%. And on the surface, this seems like a really positive clinical outcome and that behaviours are remitting over time for a substantive part of our group. However, this does leave us with 2 questions, and I'll answer these in turn. So our first question is, given this is a community sample, Is remission a result of the services and access of intervention over time? So do those with the most enduring difficulties receive appropriate services to try and help these behaviours remit? And this is something that we looked at statistically. So for self-injury, participants with persistent behaviours reported significantly more access to paediatricians. However, no more access to any other clinical services. And for aggressive behaviours, participants again with persistent behaviours over the 10-year period reported higher rates of interactions with social workers, but again, no difference among any other services. And so I think we can quite confidently answer this first question with no. Perhaps these behaviours are just going away on their own, rather than as a result of any intentional intervention. And so holding that in mind, we move on to our second question. Are there demographic and behavioural characteristics that are correlates for persistent behaviour over time? So again, first looking at our self-injury data. Along the side here, we can see variables that we looked at with our validated measures. And in this first half, we will look cross-sectionally. So at each time point, what was associated with self-injury? And we'll do this with effect sizes. So a 0 means no effect, and a cross means there was an effect. And the more crosses we see, the stronger this effect was. And what we see is behaviours associated with activity, along with autism characteristics, seem to be associated with the presence of self-injury. And we can then look longitudinally. So what behaviours taken at the original time point back in 2007 predict the later presence of self-injury? And what we see quite drastically here is that impulsivity is the only behavioural variable that predicts self-injury at every time point and is shown with a very strong effect. And looking in the exact same way at aggressive behaviours, we see a similar pattern of activity scores and impulsivity being stable behavioural variables that predict persistent behaviours both cross-sectionally and longitudinally with a very strong effect. And I'd just like to add that part of the reason we're presenting effect size is that we're conducting a very large number of tests and we wanted to be as conservative as possible. We also ran conservative regression-based approaches, so a lasso model for the self-injury data and growth curves for the aggression data, and it revealed exactly the same predictors. And we can begin to think back to what we said earlier about individualized risk in the context of potential cognitive models. Given what we now know about impulsivity and persistent behaviours over the 10-year period, we can think about how potentially an inhibition to stop prepotent behaviours may be an underlying reason for their persistence. So if we think about inhibition comprising of an inability to inhibit a prepotent response in the presence of an evoking stimuli, and a difficulty with stopping these behaviours once they get going, in the context of self-injury, for example, we might expect to see that for individuals who have higher levels of impulsivity, self-injury is evoked more easily and is a behaviour that once initiated keeps going and is very difficult to stop. So to conclude, self-injury was persistent for 44% of participants over the 10-year period and aggression in 30%. Remission of these behaviours could not be explained through appropriate access to clinical services and intervention. Behavioural characteristics of impulsivity and total activity scores provide a mechanism by which we are able to stratify risk and target interventions more appropriately moving forward. And I'd just like to say a final thank you to all the parents and families that took part in this research over the 10 years and all my colleagues that have helped with collecting the data. Thank you.
Hello, my name is Adele Dimian and I'm from the University of Minnesota. I'll be presenting predicting self-injurious behavior at age 3 for high-risk infant siblings today. I would like to first thank my co-authors and collaborators and give a special thanks to Dr. Jason Wolf, the IBIS Network, and the families that continue to participate in this study. And thank you to our funders for funding this important work. So, what we know about self-injurious behavior among people with intellectual and developmental disabilities is that it can be severe, chronic, and persistent. And despite robust behavior analytic approaches for treating self-injury, we know very little about the early emergence and development of self-injury and how to prevent it. In particular, the early punitive or causal risk factors for developing self-injury are unknown, and these are important to identify to create targeted early intervention, hopefully one day prevention programming. Our previous work to date has been to test potential risk factors identified in the extant literature from mostly adult cross-sectional research and downward extend it to at-risk infants and toddlers. We evaluated what variables at 12 months of age predicted self-injurious behavior at 24 months previously and found that lower intellectual functioning, self-injury endorsement, and stereotypy at 12 months significantly predicted self-injury status at 24 months. We also have evaluated parent-reported sensory responsivity among these same infants at risk for autism and found that hyper-responsivity and self-injury were highly correlated early on. And so in the current analysis, we aim to extend our previous findings to predict self-injury at 36 months and to test the same potential risk factors along with sensory subtypes at 12 months. We also explore the topographies and prevalence over time, as well as examine the relative risk of self-injury given an autism diagnosis. So this study is part of a larger multi-site longitudinal study called the Infant Brain Imaging Study, or IBIS, and we included 149 high-risk infants who all had an older sibling with a diagnosis of autism. 27% did go on to receive a diagnosis of autism themselves, and the Mullen, Vineland, and Sensory Experience Questionnaire and the repetitive behavior scales revised were all administered at 12, 24, and 36 months of age, and we utilized descriptive and binary logistic regressions. So self-injury point prevalence estimates based on any parent endorsement of self-injury on the RBSR were 38.9% at 12 months, 34.9% at 24 months, and 22.1% at 36 months. And the cumulative incident or new cases at 36 months was approximately 2% over 12 months. So this is a graphical display using bubble graphs to show SIB topography endorsement by time point for persistent cases on the upper panel there. And that's anybody who had self-injury endorsed at all 3 time points. The lower panel here is self-injury topography endorsement by time point for transient cases or anyone who had 1 or 2 had self-injury with at 1 or 2 time points. And the x-axis are the topographies listed in the RBSR, and the y-axis is the percent of the sample with endorsement of that topography. Now the size of the bubble indicates average severity score for the item, and the colors show the different time points. So the darkest is indicating 12 months, and the lightest here is indicating 36 months. Overall, for the persistent cases, hit self against surface was endorsed the most and resulted in the greatest severity scores, especially at 24 months. And rubs or scratches showed an accelerating trend with increased endorsement and severity at 36 months. The transient cases are also indicated hit self against surfaces as more severe, especially at 12 months, but then obviously decreased over time. And here we have the SIB topography endorsement by time point for those who received a diagnosis of autism on top, and the lower panel shows those who did not receive a diagnosis. Now the autism group had higher endorsements of topographies and greater severity scores over time. Again, hit self against surface was endorsed the most for both groups, but it also got more severe by 36 months compared to the group that did not receive a diagnosis. Also hits self with body part, inserts finger or object, and skin picking were endorsed more among the ASD group at 36 months in comparison to the group without a diagnosis. This slide displays the absolute number of participants that had emergent or new topographies reported at 24 and 36 months. For the autism group, hit self against surface was the emergent topography endorsed the most at 24 months, whereas inserts finger was endorsed the most for the group without a diagnosis. At 36 months, there was less new topographies reported within the sample overall. We also found that the relative risk of engaging in self-injury at 36 months was 4 times higher among children with autism compared to those without a diagnosis. And here are the results of the logistic regression models. Both the regression models significantly predicted self-injury at 36 months. Of the individual predictors, the Mullen composite score, presence of stereotypy, self-injury, and hypo or hypo-responsiveness, both of them at 12 months were significantly associated with self-injury at 36 months. For children who exhibited stereotypy at 12 months, the odds of self-injury at 36 months increased by 96%. Finally, the odds of self-injury at 36 months increased by 35% and 17% respectively when we added sensory subtypes into the model. So the purpose of the study was to evaluate behavioral characteristics predicting early self-injury among children at high familial risk for autism. Additional models in the future, including variables like topography, as well as maybe using latent class modeling, may help elucidate multiple pathways for identifying who is going to engage in chronic self-injury, but also may help us create a taxonomy of early self-injury. But the take-home message here really is that children with autism in particular are at high risk for early on for engaging in self-injury. And self-injury is not ubiquitous early in development. So it's important to continue this work so we can identify those risk factors for early development of self-injury and to inform prevention and early intervention programming. But more longitudinal work is warranted. Thank you for your time.
Hello, my name is Laura Groves. I'm going to talk to you today about the development of prediction models of risk for challenging behaviour in individuals with intellectual disability. So just to give a little bit of context about what happens in the UK, we are encouraged to identify those individuals at the greatest risk of challenging behaviour early, and then to deliver interventions to those individuals and their families to mitigate this risk. However, this rarely happens in clinical practice. People only really come into contact with services once their challenging behaviour has reached a crisis point, and we have no pathways in place to deliver early interventions for those children who might be at risk of showing challenging behaviour. And that means we have a really reactive system rather than a preventative system, and has led us to think a little bit more about how we can be more proactive in the allocation of our services and resources to best support those families. And that's really prompted our latest programme of work, in which we're looking at whether we can use basic science. So can we use known predictors of challenging behaviour from the literature to identify those individuals who are most likely to go on to develop challenging behaviour? And then can we use this to inform service delivery? Can we use it to tell which individuals need intervention, and also what intensity of intervention do they need based on their level of risk? And in this project, we're using a screening tool called the IRIS screening tool to build these prediction models. So just to give a little bit more information about this is a caregiver questionnaire that looks at known predictors of challenging behaviour, but also challenging behaviour outcomes. And we can group our behaviours into no behaviours, low severity behaviour, and high severity behaviour outcome for each of these 4 categories. And the aim of this research is to look at whether we can develop these prediction models of risk, and then to also evaluate the performance of these on real-life clinical data in an NHS setting. So when we actually test it out in an NHS environment, can we predict those individuals who might require intervention? And so to address this first aim, what we have is a cross-section data set of 1,095 people, and we're going to build our models on this. And what we do is we hold back 20% of the data, and we perform our analyses for the models on the first 80%. Then we do an initial test of how well it's performing on this 20%. So this just gives us an idea of, at the development stage, how well are our models performing. But then what we're going to do to address the second aim is use another data set, and these are data drawn from our NHS and our NHS, people coming into our NHS system. So these are people coming into child development centres to do a check-in with their paediatrician, or because they're coming in to get a diagnosis of autism or intellectual disability. Critically, they're not coming in because they're having problems with challenging behaviour. It's more general than that. And the idea is, can we use our prediction models on a time 1 data point to predict time 2 challenging behaviour outcomes 12 months later? We're building these prediction models using a variety of approaches. In psychology, we have a preference for regressions for these kind of problems, but they might not be sophisticated enough to deal with the complexities of these data sets. So we're also looking at different machine learning approaches, which may be more robust to this. And today I'm just going to talk about these 2 approaches. So the first stage, and also is just to say, there's a lot of data here. So what I'm going to do is just focus on self-injury, but we have done this on all the different behaviours, but all the data here I'll show you is just on self-injury. And the first stage is really to just start building these models using that 80% that we started with at the beginning. So this is done by running our regressions and our random forest classifiers, and we can start to build our algorithms from those variables that best predict our outcomes. That can be shown through the coefficients and significance figures from the regressions and our variables and importance in the random forest classifiers. And then what we can do is start to predict which individuals are going to go on to develop self-injury. So we're applying these predictions to the 20% of people that we held back initially, our internal validation data set, to just get an idea of how well these are performing. And these are shown for our confusion matrices. So we have made the rows show our predictions of no challenging behaviour, low severity and high severity. And then the columns are the observed behaviours. So here are the two confusion matrices for the regressions and random forest classifiers. And the first thing to look at is the dark green diagonal, and that shows our true positives, the number of people that we're just able to correctly identify. And you can see there that the random forests are kind of outperforming the regressions on that measure. And we can also show the sensitivity and specificity of each of these classifications. And again, the random forest classifiers are performing at the level or greater than the regressions, but shows it might be just a more robust prediction model than our usual regression approaches. But I just want to draw your attention to these statistics here, because I think they're really important to understand when we're thinking about using these models to predict risk in a real life environment. So the light green here represents those individuals who have been incorrectly classified, but they are still receiving an intervention. Their behaviour indicates that they probably required some intervention, and we actually identified that they did need an intervention, but it's not at the right level. So it is an error, but it's not as great an error as those people falling into this red zone. So these are people that we've identified as not needing an intervention, but actually they would benefit from that. And that means they're kind of slipping through the cracks. They're getting missed from services. And it's the one that I guess I'm most concerned about. And if you look at that statistic, you can see that the random forests are outperforming the multinomial logistic regressions. It's only missing 3% of individuals, whereas the multinomial logistic regression is missing 20%. And the blue represents those individuals who are receiving an intervention based on our algorithm, but they may not need it. So it's that misallocation of resources. And just to show you how, that's just how we kind of the first look of how those were performing on our sectional data set, but I just want to show you how the regressions performed on an external data set. We're just at that point for the regressions. So those, that's how it would run in an NHS setting, with just people coming in for like general contact with a paediatrician or other kind of healthcare professional. And you can see that if you look across those statistics that I showed you earlier, it's performing at the level as expected in the development data set, which is really promising, because it shows that actually, even when we apply these models to a totally different population in a way that actually would, how it would run in the NHS, it's performing at the level that we would expect. So that's really promising. So in summary, the multinomial logistic regressions have shown some ability to predict behaviour. I think they're not perfect. A lot more refinement is required. And so that's important to kind of consider. The preliminary stuff from the random forest classifiers is really promising, and it might improve the sensitivity and specificity relative to the multinomial logistic regressions. And it'd be exciting to see how that performs not only in the external data set, validation data set, but also how the other machine learning approaches fare as well. So I just want to say thank you to our families, to our collaborators and funders, and also thank you for listening.
Hi everyone, it's great to be part of the Biology to Behaviour, Modelling Cause and Intervention for Problem Behaviours Symposium here at the Gatlinburg Conference. Thanks so much, Caroline, for the introduction and putting this symposium together. My name is Scott Hall, and I'm going to talk about the outcomes of a randomized controlled trial that we conducted here at Stanford for boys with Fragile X syndrome. Specifically, we examined whether administration of a behavioral treatment called functional communication training could be delivered successfully via telehealth to treat problem behaviors such as aggression and self-injury in the syndrome. Okay, so I'm going to start with a brief background to the study. Prevalent studies suggest that boys with Fragile X are at high risk for developing problem behaviors. Over the past few decades, the focus has been on identifying pharmacological treatments to ameliorate symptoms. And as a consequence, behavioral treatments are rarely conducted in this population. Part of the problem is that Fragile X is a rare genetic syndrome, and families of children with Fragile X are therefore widely dispersed across the country and don't always have access to behavioral treatment. Delivering interventions via telehealth may therefore help to decrease treatment access barriers. The purpose of this study was to examine the impact of behavioural treatment not only on rates of problem behaviours in children with Fragile X, but also the impact of the intervention on family well-being and the acceptability of the treatment. Boys with Fragile X were recruited into the study if they had a confirmed diagnosis, were aged between 3 and 10 years, and exhibited problem behaviour on a daily basis according to items on the Behaviour Problems Inventory. We included families who had high-speed internet in their home, and the children were on a stable medication regimen. Families also had to be available to receive treatment over 12 weeks. We screened 278 families of children with Fragile X and found that 158 families met the inclusion criteria, and we randomized 60 families to either treatment or control. Caregivers randomized to the treatment group were coached to implement behavioural treatments with their child in 1-hour sessions via telehealth over 12 weeks with a board-certified behaviour analyst. And families randomised to the control group continued with any treatment as usual, but did not receive treatment from the study team. This map shows the locations of the families in each group. As you can see, the families were quite spread out across the US, with many families living on the East Coast, thousands of miles away from our research base. A member of the study team, who was a board-certified behaviour analyst, visited each family in their home to conduct a functional analysis to identify the functions of the child's problem behaviour. We then based the treatment on the functions of problem behaviour identified. Each family received an iPad with Zoom pre-installed and Bluetooth earbuds so that we could coach the caregiver via video conference on their iPad. This is what a typical session looks like from the iPad that was placed on a stand in the room in the family's home. Children engaged in problem behaviour primarily to escape from tasks and transitions and to access preferred items. And so parents were coached to reinforce alternative, more appropriate forms of communication and to minimise inadvertent reinforcement of problem behaviour. We conducted in-session observations of problem behaviour from the videos, and sessions were conducted 4 to 5 days per week and gradually tapered down to once per week depending on progress. The other outcome measures we used were the aberrant behaviour checklist and the treatment acceptability rating form. 24 children completed the 12-week treatment. In terms of the in-session rates of problem behaviour, you can see that mean levels of problem behaviour were quite high at baseline during the functional analysis and decreased fairly quickly during the first few weeks of treatment to about 1 occurrence of problem behaviour per minute on average. So while we didn't eliminate problem behaviour by any means, it occurred at a much lower frequency than at baseline. Here are the trajectory of scores obtained on the subscales of the aberrant behaviour checklist at baseline and across treatment weeks. Mixed effects analyses indicated that those who received treatment evidenced significantly greater decreases in scores on the irritability subscale of the ABC, as well as on the hyperactivity non-compliance subscale compared to the control group, with effect sizes of 0.65 and 0.58 respectively. In terms of treatment acceptability, the intervention was rated as highly reasonable and effective by caregivers who were very willing to carry out the intervention with their child across the treatment weeks. The side effects of the intervention were rated as relatively low, and the disruptiveness to the family and the cost of the intervention in terms of time and resources were rated as neutral. So to summarize, we found that function-based behavioral treatment administered via telehealth resulted in significant decreases in problem behavior, with outcomes fairly similar to those reported by David Wacker and his colleagues for children with autism over the past 10 years. This demonstrates that addressing the social functions of problem behavior is important for achieving behavior change in Fragile X. Overall, the acceptability of the treatment was quite high, with families being very willing to implement the treatment. Empowering parents by teaching them strategies to manage their child's behaviour is likely to be better for longer term outcomes, and a follow-up study is now underway to determine whether parents are continuing to implement the strategies they were taught and whether booster treatment sessions may be needed for these families. Ultimately, it will be important to determine whether treatment via telehealth is as good as, if not better, than traditional in-person treatment. I'd like to end this presentation by thanking the John Merck Fund for providing the support for this study and the families who gave up their time and participated. Thank you very much, and I hope you enjoy the rest of the conference.
Hello, everyone. I told you I would, turn up again like a bad penny. I'm the discussant on today's symposium, From Biology to Behavior, Modeling Causes and Intervention for Problem Behaviors. Caroline Richards is the chair and orchestrated this yet again another data blitz from the aberrant behavior crowd of Gatlinburg. And for my American friends and colleagues out there, don't be alarmed. That is the word behavior. I grew up Canadian, so hats off, shout out to Caroline and our UK friends and colleagues for the Queen's English there. So, discussant, SIB. It's modeling problem behavior, and some of the data sets have aggression and severe problem behavior. All of us had self-injury. You know where I'm coming from, so I'm going to center on some comments on SIB, self-injurious behavior. And this is in reaction. I read all of the abstracts. In today's pandemic constraints, I had not seen all of the slide decks from everybody. So if I've missed out on key details, I apologize. I read and studied the abstracts, and so here's some thoughts and reflections on those. So that was then. I was thinking of, while I read those, what would it have been like, when I started hanging out in Gatlinburg 2 decades ago, thinking about SIB, assessment, treatment, frequency, severity, function, topography, or form, right? We talked a lot about these things. So in reading this symposia's abstracts, this is now, and the early career and mid-career scientists that are part of this symposia, here's some words that we didn't used to talk about 2 decades ago in this context of SIB and severe aberrant behavior: longitudinal, cohort, measurement wave, machine learning, modeling, prediction, risk reduction, telehealth, RCT, outcome measure. This is very exciting. So this was for me really an interesting progression of the way people are trying to think. Oh, and biomarkers, the way we're trying to get our handle on this very old problem. So earlier in the week, I was yet again humbled and schooled by Dr. Jim Bodfish, who served as a discussant in a different symposia that I was part of participating in, and he had a way with words and included some very important quotes to help think about some of the issues. And so I'm taking a page, as usual, out of his book, and I was thinking in a way to organize my reflections on the abstracts and the issues identified in our talks. I have 3 quotes that I'm going to reflect on. One from Jerome Bruner. I had development on my mind. Clearly, he made contributions in cognitive psychology, but also developmental psychology. John Dewey, I'm thinking about pragmatism. And then George Box. For those of you who know George Box, that's one of the classic quotes of all time. Modeling. So development, pragmatism, and modeling were on my mind. So the essence of creativity is figuring out how to use what you already know in order to go beyond what you already think. So in our world, I think of those of us in this aberrant behavior, severe ID, severe developmental disabilities, what do we already know about development and risk, or what do we think we know? And I think what we think we know, most of what we know, is based on cross-sectional designs with single time point measurement across demographic and clinical status variables. That's informing what we know, what we think we know in our conventional wisdom. So what do we know right now, thinking about the new data sets in front of us in the symposium, as it relates to development and risk? Well, development and persistence of SIB. So the Laverty paper, I highlighted a couple things here. So risk factors for persistence, this idea of this construct that we see with Chris Oliver and Caroline and that group about psychological variables, impulsivity and hyperactivity. Just some other things of note here. 10 years. 10-year window, 3 measurement waves. I got little exclamation points after these. I'm emphasizing these. I don't know if I'm going to pronounce it right. lasso modeling to identify baseline impulsivity and what I'm going to characterize as some affective variables that are predicting over a 10-year period persistent SIB. I think aggression came in around 30%. 44% of the SIB is persistent over 10-year sampling, 3 measurement waves. Let's dial back in the age and go all the way down, 12-month-olds with Adele, Dimian, and Cruz paper. 3 measurement waves, an N of 149. It's prospective, starting at 12 months. SIB and stereotypy predicting a 12, 3 years out. But also this notion that's construct hypo-responsivity. So trying to think again beyond maybe the standard demographic status variables. And they showed up too, lower IQ, impairments in adaptive functioning, but other mechanism relevant or theoretically informed variables that might help us account for the why underlying kind of the associated, the associations. Okay, so I'm not familiar with that. So it's not that, it's this. Statistics, machine learning, it's a regression analysis method that performs both the variable selection and the regularization in order to enhance predictive accuracy and interpretability of the resulting statistical model. So you can see where I'm going. Statistical model, all models are wrong, some are useful. Where are we going to find our useful models? Where are they going to come from? Well, Grove et al. Comes in. Quote, the aim of the study was to use machine learning to develop a predictive model. I'm going to say that's a useful model. Identifying individuals at low, moderate, and high risk of challenging behavior. They had a secondary aim, assessing the validity of the model to predict future levels of challenging behavior. Machine learning, an N of 732. OMG. Come on, guys. Think of these 3 data sets, N's of over 100, 3 waves of measurement, predictive modeling, assessing the validity, getting algorithms built to help us sort, stratify. This is exciting stuff. Okay, but we do not learn from experience. We learn from reflecting on experience, says John Dewey. Well, what's our experience in this area? Our most robust experience or evidence base is the discovery of behavioral mechanisms regulating self-injury and the replicated treatment demonstrations based on mechanism identification. Our standard functional analysis leading to functional communication training, or more broadly, functional-based interventions in our language, right? Function. So the next stage of learning from reflecting on experience, what is that? How about you leverage technology, extend the model, use a randomized clinical trial to start generating efficacy and effectiveness evidence for comparative effectiveness of the model? Well, how about Scott Hall and colleagues? I mean, it's amazing. Clear, compelling effectiveness and social validity data and a sample of Fragile X, all generated by a single well-conceptualized and well-executed randomized trial, putting in the evidence into the evidence base for how to learn from our experience and move forward. So, a few more comments. Where are we going, friends and colleagues? There's a gentle nudge from me. So if we're getting into modeling, and I'm saying just what I just saw, 3 papers minimally. I'm going to gloss over mine, but we're going to model. That's good. Let's think about models for a purpose. And George Box's reminder: all models are flawed. Some are more useful than others. So if we're going to start modeling, let's build useful models, predictive validity evidence, and test by doing. It's one thing to keep identifying that we know there are correlates. The more severe the intellectual impairment, the more likely of SIB. But what's the causal relation? What are the malleable risk factors? What are factors we can do something about? So that's my test by doing idea. Measures. We might need to consider harmonizing. We're a small group. We have some similar measures, but we have other measures that maybe are dissimilar. So we don't, it's not necessarily clear that we're always talking exactly about the same thing. Measurement for a purpose. The purpose primarily for many of us, at least how we got started, is tertiary. It's case management. It's count, frequency, count, duration, severity, and then try to assess and intervene. But if we're shifting to modeling and risk, then we might have a different agenda emerging about what our measurement should be in service of. And maybe it's more about secondary or primary prevention. And that's going to look different than some of the ways we've approached measurement for tertiary purposes. Trials. We're close, but we can keep pushing ourselves to think about multi-site collaboration. Treatment. The targets vary by goal. Again, if the goal has been tertiary of a well-established self-injury case that needs to be treated, which they do, that's one thing. But if the goal and treatment targets are informed by a secondary or a primary prevention perspective, the targets are going to look different, I think. Theory, where did it go, right? So there's sort of two worlds, the epi prevalence estimates, and then we had theory models, opioid theory, arousal, and elements of that show up. We've got Caroline from Chris and impulsivity, but let's keep thinking of how to bring in the theoretical pieces to our modeling, as opposed to the standard status variable correlates, but the potential mechanisms that the theory could pull in. So I'm going to end on this. Words I didn't use, but some of you will, our early career colleagues, as you move the field forward. Risk detection, screening, trial readiness, precision early intervention, implementation science, prevention, family advocacy, policy. This is coming based on what I just saw in this symposia. Those are words, phrases, concepts, and constructs that I listed earlier that weren't there 20 years ago. So we're moving, folks, even if it doesn't always feel that way. And with that, I'll stop and thank you very much.